Okay, so 75, area of a trapezoid. That's the second part of today. And here's a trapezoid. Trapezoid has one pair of parallel lines only. Trapezoids come in lots of different shapes, but trapezoid has one pair of parallel lines. Trapezoid is, you could imagine your trapezoid being part of a larger rectangle. You could imagine that your trapezoid fits in part of another shape. This is just one way that shape could appear. But when you're talking about a trapezoid, you have to do something a little bit different to figure out its area. And the area of a trapezoid then is this. Because a trapezoid would fit, that was the worst trapezoid I ever drew. Let's erase that one. Your trapezoid could also fit into a rectangle that looks like this. Okay, notice this time your rectangle goes outside of it. So when you do the area of a trapezoid, you cannot use your diagonal angles to help you solve it. And if you also notice, a triangle is half of a rectangle. A triangle is going to be half of a trapezoid, like this. You can divide a trapezoid into two triangles, two equal triangles. So therefore, the formula for the area of a trapezoid is this. A equals, write this in your notebooks, 1/2. It's a little bit complicated. Base 1 plus base 2 times the height. Your trapezoid has two bases. It has a shorter base and a longer base. Okay? And because we could divide a trapezoid into two triangles, we will kind of combo attack the area of a triangle with the area of a rectangle. Which means what we, in essence, do is we split the difference of the two bases. We find the average of the two bases. Because we got two bases, we add them up and divide by 2. That's like doing average, isn't it? Then we multiply it by its height, not by its diagonals. So if I drew this particular trapezoid, which, since Joe's not here, if you were a Star Wars person, this looks like something. Here's the height. Okay, we have two bases and we have a height. The Jawas, yeah. So the Jawas, little transport. All right, so using that formula, I would do A equals 1/2 10 plus 7 times 6. Because I did 10 for my first base. My second base was 7. I'm going to add those two up, which is, what's 10 plus 7? 17. I'm going to divide that by 2. Or I could divide 2 later. I could do, because 17 is not an even number, is it? So let's wait on that. Because does order matter in multiplication? And is order going to matter when we do this, when we multiply by 1/2? Okay, what's 17 times 6?
102.
102?
Yeah.
What's 102 divided by 2? Because it's 1/2. So it's 51. And I didn't tell you the dimensions, so I'll tell you now. There's centimeters. So 51 square centimeters. Since our order isn't going to matter, we could do that by 51. And we got it. 51 square centimeters. Now here's another trapezoid. Okay, looks a lot like the complex shape we did at the beginning. This one is 5 feet 11 inches, 7 feet 2 inches for the height, and the bottom base is 10 feet 1 inch. Well, I'm not going to be mean enough to tell you figure it out that way, so let's estimate it. 5 feet 11 inches is darn close to 6 feet. 7 feet 2 inches is close to 7 feet. And 10 feet 1 inch is close to 10 feet. All right, so we do 1/2 times base 1, which is 6, plus base 2, which is 10, times 7. So 6 plus 10 is?
16.
Half of 16 is? And 8 times 7 is? So 56 square feet.
Is this what we're going to do for like that kind
Yeah.
of stuff?
Yeah. So we showed you two things: area of a trapezoid and then area of a complex shape. Now sometimes when you do your areas of a complex shape, I'm not going to solve this one because we've already done some of these, but your complex shapes might be as complex as this. And you would divide this up. You could divide it up right here. You could divide it up here and then here as well. So you could divide them up a couple of places. And if your shape was a little more simple, like this one, you could also do that subtraction method by finding the area of the whole thing. Okay? There you go. Lesson 75.